In our next video, we will explain the difference between data analysis, analytics, business intelligence, and big data. These terms are used interchangeably in many organizations. However, there are some fundamental differences between these terms, which will help us to understand why big data environments require a different setup. In the business and scientific domains, 4 forms of pattern identification in datasets are commonly used, which include data analysis, analytics, business intelligence, and big data. Before explaining why big data requires a different setup and architecture, it is essential to differentiate between these terms. Let's begin with data analysis. Data analysis is the process of examining, cleaning, transforming, and interpreting data to extract meaningful insights. It involves using various statistical and mathematical techniques to discover patterns, trends, and relationships within the data. Data analysis often focuses on past data and is primarily retrospective, seeking to understand what happened and why. Now, let's move on to analytics. Analytics goes beyond data analysis by incorporating a broader set of tools and techniques. It involves using statistical models, algorithms, and machine learning to predict future outcomes and trends based on historical data. In essence, analytics aims to answer the question, what will happen next? Or, what is likely to happen? This forward-looking approach empowers businesses to make informed decisions and plan for the future. Let's dive into data analytics a bit more in detail since many analytics techniques will be used in big data environments. There are 4 distinct types of analytics that serve different purposes in understanding and utilizing data. Descriptive analytics focuses on past events, providing a summary and visualization of historical data. Diagnostic analytics seeks to understand why something happened by identifying root causes and contributing factors. Predictive analytics forecasts future outcomes based on historical data and trends using statistical and machine learning techniques. Prescriptive analytics recommends the best course of action to achieve desired outcomes by leveraging optimization algorithms and simulations. Descriptive analytics focuses on understanding past events by examining historical data. Its primary goal is to provide a summary and visualization of data to gain insights into patterns, trends, and key performance indicators, KPIs. Descriptive analytics answers questions like, what happened, and how did it happen? Examples include basic statistical measures like averages, totals, percentages, and data visualizations like charts and graphs. Diagnostic analytics aims to understand why something happened in the past. It goes beyond the basic what and how questions of descriptive analytics to identify the root causes and factors that led to specific outcomes or events. Organizations can uncover the drivers behind their performance metrics by conducting a deeper analysis. Diagnostic analytics helps answer questions like, why did it happen? And what were the contributing factors? It involves techniques such as root cause analysis and correlation studies. Predictive analytics focuses on forecasting future outcomes based on historical data and trends. It uses statistical algorithms, machine learning, and data mining techniques to make predictions about future events or behaviors. Predictive analytics seeks to answer questions like, what is likely to happen in the future? By identifying patterns in the data, organizations can make informed decisions and take proactive measures. Common examples include sales forecasting, customer churn prediction, and stock market trend analysis. Prescriptive analytics is the most advanced form of data analysis. It not only predicts future outcomes but also provides recommendations on what actions to take to achieve desired results. Prescriptive analytics leverages optimization algorithms and simulation techniques to suggest the best course of action among various options. It answers questions like, what should we do to make it happen? Prescriptive Analytics empowers organizations to optimize processes, resources, and strategies for maximum efficiency and effectiveness. Now that we have seen data analysis and 4 different forms of analytics, let's switch to business intelligence, frequently abbreviated as BI. Business intelligence is a comprehensive approach to data management and analysis. It involves the integration of various data sources to provide a holistic view of a business's performance. BI tools and dashboards help present data in a user-friendly manner, making it easier for stakeholders to grasp insights quickly. Business intelligence emphasizes real-time or near real-time data monitoring to support tactical decision-making within an organization. Business intelligence solutions have been around since the early 1980s. The primary challenge that business intelligence systems solved was consolidating the information from different databases in the enterprise. By consolidating the information, it is possible to see patterns or create reports across different information systems. Consolidating different databases into a centralized data repository is known as a data warehouse. Data warehouses are therefore tightly integrated with BI solutions. A data warehouse is, in most organizations, a centralized repository that contains copies of different datasets in the organizations. Let's explore how this works in a little more detail. The following picture gives a good visualization of the business intelligence process. In BI systems, structured data from various sources is imported into a centralized data warehouse. This is typically done through an ETL operation, which stands for extract, transform, and load. Copies of the data are then stored in the data warehouse, and this data warehouse can be queried by reporting engines. These reporting engines frequently use online analytical processes, or OLAP, to create reports. In a few moments, we see how this is different from big data. Now that you know how business intelligence works, take a moment to think about what you learned in the previous modules. Why would big data be any different from a business intelligence system? To find the answer, let's reflect on what we have learned so far. Remember that big data is characterized by 4 key characteristics, known as the 4 Vs: volume, velocity, variety, and veracity. Big data technically make use of both data analysis and analytics technique in handling the scale and complexity of the data. It often builds upon the data in enterprise data warehouses used in business intelligence, BI. In many ways, big data can be seen as the next step in the evolution of business intelligence, as it takes data analysis and analytics to a new level of complexity and sophistication. But there are also important differences, which is well indicated by the picture on this slide. Big data differs from business intelligence in 2 important ways. First of all, the volume of data analyzed in big data is much larger than what traditional BI solutions can handle, requiring unique storage and processing solutions. Secondly, big data encompasses a variety of data sources, including unstructured or semi-structured data, such as images or audio files, that require specific processing capabilities. As a result, big data solutions need to be able to handle and analyze data in ways that traditional BI solutions cannot. Let's summarize what we have seen in this video. Data analysis involves examining historical data to understand what happened. Analytics uses statistical models to predict future outcomes based on past data. Business intelligence integrates data from various sources and presents it in a user-friendly format for real-time decision-making. Lastly, big data deals with vast and diverse datasets that require advanced technologies for processing and analysis. Know that you know these differences, we can proceed with explaining what technical capabilities are required in big data environments.